Hello there. I'm Nurul, and I'm working on quite a few things to keep the different sides of my personality in action. So when I'm motivated by disease and death, and I really want to fix healthcare, um, that's happened quite a lot in my life. And so I started working on Onito, which is an AI suite for hospitals, so that doctors can leave the aspects of diagnosis and treatment that a computer can do to the computer, and they can focus on what a computer can't do yet. So how this works is, for example, ChexNet is a machine learning model that was made by Stanford, and it can generate a prediction using an X-ray for it can generate a prediction for pneumonia, and with 83% accuracy, which is pretty great considering an actual human radiologist can only do it with 78% accuracy. So I'm trying to get these sort of AI models to hospitals, and that is Onito. When I want to give power to the people, against corporations and stuff, that's a big motivation of mine, Web3ifying the world. So with that motivation, I'm working on renewable energy using rainfall. So I live in Mumbai, and Mumbai doesn't have so much sunlight, so solar energy is not that popular here. But it does have a lot of rain, and it has a lot of tall buildings. So what struck my mind was, what if you have a reservoir on top of a 30-floor building, and it collects rainwater, and the rainwater is allowed to fall and generates electricity through a turbine for the people who live in the building. That's something I'm working on. I'm researching whether it's feasible or not. Along with this, I'm working on a decentralized framework for energy generation, because nobody owns the sun, nobody owns wind. Why should big corporations make money from them? So, kind of a cryptocurrency for energy, sort of the work that Single Earth is doing, but a little more decentralized to normal people like you and I can use it, and normal people like you and I can sell electricity on the grid, and generate our own electricity through mediums like solar panels or the rainfall thing that I was talking about. So that's something I'm working on too. Another thing that I'm working on is combinatorial explosion. So anybody familiar with computer science would definitely know that this problem is so common in this thing. So in CS, that TSP and so many things suffer combinatorial explosion. So like you have n things, and you have to select certain ones that are the best out of them. So you have to check n things, right? So I'm working on that. So you have to work with a lot of randomness in that. These things are randomly distributed, and you have to sift through the randomness to find something that is actually useful to you. Evolution does this in such an amazing way, like random mistakes in genes, which one is going to survive, which one is going to succeed. And that's what evolution does. It just sifts out the good stuff from the useless stuff. And so I'm trying to use computational evolution to work on certain problems like TSP and even prime numbers and stuff. Another thing that I'm doing is computational cell modeling, because I want to digitize the brain, frankly. And well, this might be a little too much, but kind of work on immortality and stuff. So to digitize the brain, what I did was, for computational cell modeling, what I did was I studied introductory biology and neuroanatomy from MIT, and I built certain algorithms and stuff, computer science algorithms that explain cell function. And I did this research under a mentor in biotechnology. So I want to explain how a cell works in terms of computer science, so that for two reasons: one, so that a computer can understand it and simulate it, but two, so that computer science researchers can understand it and build upon it. So I'd love to be part of the India Fellowship, so I don't have to worry about funds for a couple of months, and obviously get a little bit of exposure and opinions and reviews, especially critical review of my ideas. And yeah, thank you for your time.